Hello, dear friends. Yet another live streaming in continuation with yesterday's important concept of sum and product of zeros of a quadratic polynomial. Now, we have done one video on this yesterday in which we did the basics of this important video today. And Today we are going to solve some of the complicated problems which are quite prevalent in board exams. So as I am joined by my students, I'm just waiting for more of my students and subscribers to join in. In the meanwhile, I'll just get on with the concept which we did yesterday so that we can just revise. I told you that a quadratic polynomial is denoted by ax square plus bx plus c, and in this quadratic polynomial there are two zeros because the degree of the polynomial is 2. Zeros are denoted by alpha and beta, and there is a relationship between these zeros and the coefficients a, b and c. Always the sum of zeros, that is alpha plus beta, is obtained by negative coefficient of x upon coefficient of x square, and the product of zeros, alpha beta, is obtained by c upon a. Now this is a concept which we are going to use today in some of the problems related to the chapter on polynomials. So as I welcome Vidhi, Hardik, Sachin, Syed, Yuvraj, Pradeep, Neha Sharma, Mohammad Aslam, Nitin, HH Productions, I don't know, with the name I can't identify you. Kishore, yeah, hello and welcome to all of you students, and I hope you will have a very good learning session. Surendra, yeah, you were there yesterday, so I'm glad you are there today also. Amrendra Chahal, Chandel, okay, yeah, hello. Kamaljeet, okay, so I think we have sufficient number of students who have joined in, so we can carry on with the first one. Pratyaksh, hello and welcome. Amisha, good evening. Vijay Lakshmi, hello. Okay, so I'll take a basic small problem. In the meanwhile, we can welcome more subscribers. Now, this is a concept. If anyone has not seen the concept till now, this is the main concept which we are going to use in the problems. So remember, whenever alpha and beta are the zeros of a given quadratic polynomial, then alpha plus beta is always obtained by negative b upon a, and alpha beta is obtained by c upon a. Vidhi, live stream, you are chatting on the live stream itself. Maybe you have connection issues there. Manoj, welcome. Kiran, welcome. And good evening. Okay. So now I am taking up one problem, little simple example, so that anyone who joins late can also understand. So I'll let the concept be here for one question. Now the question goes like this. This is the first question we are going to do today. If alpha and beta are the zeros of, if alpha and beta are the zeros of, now there is a quadratic polynomial which is given whose zeros are alpha and beta. The quadratic polynomial is 2x square minus 3x plus 5. If alpha and beta are the zeros of this quadratic polynomial, comma, find the value of I'll take one example. Say first part 1 upon alpha plus 1 upon beta, and the second part alpha square plus beta square. Now these are the two parts which we have to do. Remember students, for these questions we don't need to find the zeros of this quadratic polynomial. We will use the relationship between the zeros and the coefficients, that is alpha plus beta is minus b upon a and alpha beta is c upon a. So for using these two relationships we can surely find the values of any desired expression here. Now let me tell you how. The solution for this goes like this. Now see, in the given polynomial 2x square minus 3x plus 5, we have the values of a, b and c. The value of a is the coefficient of x square, this is 2. The value of b is the coefficient of x, that is minus 3. And the value of c is the constant term, that is 5. So we have all the three values of a, b and c. Now since we have a relationship between the zeros and the coefficients, we can write the two relationships. See, alpha plus beta is denoted by minus b upon a. Here is the formula. And just put the values here. Minus b is minus 3 upon a is 2. So you get 3 upon 2. So you have got alpha plus beta as 3 upon 2. Now come to the second relationship, alpha beta. The formula is c upon a. What is the value of c? 5 upon a. The value of a is 2. So these are the two relationships which we will be using for finding the values of desired expressions. I hope finding the value of alpha plus beta and alpha beta is clear to you. Yeah, audience, Varsha has already come up with the answer. I'm so glad. So I hope you have understood how to find the values of alpha plus beta and alpha beta. I'm waiting for the response by my students. Any doubts still here? Because in all the questions you will be doing this part. Okay, now we can find the value of the first expression. The value of the first expression is 1 over alpha plus 1 over beta. So just take the LCM, alpha beta, and in the numerator you have alpha plus beta. Now this is the trick to solve these questions. You have to convert this expression in the form of alpha plus beta and alpha beta. So because the values of alpha plus beta and alpha beta is known. Now substitute the values. Alpha plus beta is 3 upon 2 and alpha beta is 5 upon 2. So the 2 gets cancelled and your answer for the first part is 3 upon 5 as already suggested by so many of you. In the second part, you have alpha square plus beta square. So remember students, whenever you have alpha square plus beta square, then you don't need to solve this expression because already the terms are unlike terms. You need to remember a small identity of alpha plus beta whole square. From there you can derive this. So the expression for alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. This is something to remember, alpha plus beta whole square minus 2 alpha beta. Now substitute the values here. Alpha plus beta is 3 upon 2 square minus twice of 5 upon 2. So this is 9 upon 4 minus 5. 9 minus 20 upon 4. So your answer for this question is minus 11 upon 4. So the second part, I hope now you have got it because the answers which you have given don't seem to be correct. Varsha, you got 29 by 4. I think you applied a wrong formula there. Alpha square plus beta square, the value is always obtained by alpha plus beta whole square minus 2 alpha beta. Students, please copy this because it is a very important question. And if you don't know this question, then the subsequent questions will be difficult for you to solve. Vidhi minus 11 by 9, kindly check the denominator. It's not 3 square, it is 2 square, 4. Pradeep, you want me to repeat the second part? The first thing is the formula for alpha square plus beta square. So whenever you have to find the value of alpha square plus beta square, you have to derive that value from alpha plus beta whole square. So alpha plus beta whole square minus 2 alpha beta. Now put the values of alpha plus beta and alpha beta here, you get the answer. Sir, why we put 2 alpha beta? Anmol, sir, why you have put 2 alpha beta? You want me to answer that? Okay, see, alpha plus beta, I think you can see this, alpha plus beta whole square. The identity for alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. So if you take this term to the other side, this identity will come. Alpha square plus beta square, the identity will become alpha plus beta whole square minus 2 alpha beta. So that is the reason why I have put minus 2 alpha beta here. Sachin, why? Sir, we can't take alpha and beta common. Where is alpha and beta common in this, Sachin? There is no beta here and there is no alpha here. Nothing is common here. Yes, sir, I have made it correct into second comment. Okay, fine. Vidhi, if you got that right. Okay, no more doubts, I think. So we can get on with the typical problems now. So students, now if there is any doubt, you can still ask me, because subsequent problems will be a little bit tougher. Okay, fine. Let us get on with that now. Okay, let us have one more question. This is second question. If alpha and beta are the zeros of, now you are given a quadratic polynomial. This is 4x square minus x plus 3. 4x square minus x plus 3. Find the value of. Find the value of. Now I will take some more parts. Now see, whenever you are given a question like this, the first thing is to find the value of alpha plus beta and alpha beta. Only then you can simplify whatever is asked in the question. So now the first part is alpha square beta plus alpha beta square. I'll just tell you how to convert all this in the form of alpha plus beta and alpha beta. Alpha cube beta plus alpha beta cube. This is the second part. Third part, 1 upon alpha square plus 1 upon beta square. This is the third part. Fourth part, alpha cube plus beta cube. Fifth part, alpha minus beta. And sixth part, alpha square minus beta square. Now see, the values of all these different expressions have to be calculated, and how you calculate all these values. Now, see, if you know how to simplify these and bring it in the form of alpha plus beta and alpha beta, then things become very simple. Now, in this, alpha beta is common. So, we can take alpha beta common in the first part. So this is alpha beta and you get alpha plus beta. Now you can substitute the values of alpha plus beta and alpha beta, which will be obtained through the relationship. Now in the second part, I am just giving you hints. The answers will be calculated by you. In the second part, again you have alpha and beta common. So if you have alpha and beta common, then you get alpha square plus beta square. Now still this is not in the form of alpha beta and alpha plus beta. Alpha beta is there, but alpha square plus beta square, again you have to use the formula which you have done in the first question. So here what you need to do is to write alpha beta and then write the formula for alpha square plus beta square. This is alpha plus beta whole square minus 2 alpha beta. And here we go. Now we have converted everything into alpha plus beta and alpha beta. Now you can substitute the values. I am just giving you hints how to convert all these expressions in the form of alpha plus beta and alpha beta. Now the third part. Now see, take LCM, alpha square beta square. In the numerator you will have alpha square plus beta square. So again in the numerator you have alpha square plus beta square. So same identity will work here also in the numerator. So this is alpha plus beta whole square minus 2 alpha beta. And in the denominator you have alpha square beta square. So alpha beta whole square. Now you can put the values because I have converted that into the same two expressions. In the fourth part, alpha cube plus beta cube, again you have to remember this. How? This is alpha plus beta whole cube. You have to find alpha cube plus beta cube from alpha plus beta whole cube identity. So alpha plus beta whole cube minus 3 alpha beta alpha plus beta. So this is the straightforward formula for alpha cube plus beta cube which you have to remember. So if you don't remember it, then you can derive this from alpha plus beta whole cube formula. So now you can put the values and find the value of this expression. Fifth one also, now again you have to remember this. This is square root of alpha plus beta whole square minus 4 alpha beta. Again something you have to remember. From alpha plus beta whole square we can derive this relationship also. Now you can put the values and find the value of this expression also. Now for the final part, alpha square minus beta square, this is alpha minus beta into alpha plus beta. So alpha plus beta will remain as it is because already that expression is converted. And alpha minus beta will be calculated just as in the fifth part. So under root alpha plus beta whole square minus 4 alpha beta. And now you can find the values of all the expressions. See, I have told you how to convert all expressions in the form of alpha plus beta and alpha beta. So now you can tally your answers. See, the value of alpha plus beta and alpha beta from this expression is, say, alpha plus beta, I'll write it here because I think that is not visible. So alpha plus beta will be minus b upon a, so minus b is minus 1. So minus 1, that is 1 upon 4. So I have used minus b upon a. And alpha beta is c upon a. C is 3 and this is 4. So 3 upon 4. Now you can put these values in all these expressions and get your answers. So the answers, I will just do it in the rough work and write the answers here so that you can tally your answers. The first one, alpha beta is 3 upon 4, alpha plus beta is 1 upon 4. So 3 upon 16, the first part. I am writing only the answer. Please do all the steps and you can tally your answers. Second one, alpha beta is 3 upon 4, alpha plus beta 1 upon 4 minus 3 upon 2. So alpha beta is 3 upon 4, alpha plus beta 1 by 4 square 1 by 16 minus twice of 3 by 4, that is 3 by 2. So 3 by 4 into, so LCM is 16, 1 minus 24. Okay, so this is 3 by 4 into minus 23 by 16. So you get minus 69 upon 64. This is the second part answer. So I don't think many of you have got that answer. Sachin, you got minus 69, but in the denominator you have written 16. So I think you missed out that 3 by 4 outside. The third part, this is 1 by 16 minus 3 by 2 upon 9 by 16. So alpha beta whole square. So this is 16, 1 minus 24 and 9 by 16. So 16 gets cancelled, minus 23 by, so if this is visible, okay, minus 23 by 9. This is the answer for the third part. I hope you are substituting and not just copying the values. Hardik, I think you joined in late today, so you have not understood that. You need to see it from the beginning because now it will be very difficult. Fourth part, alpha plus beta 1 by 64 minus 3 alpha beta 3 by 4 and 1 by 4. So 1 by 64 minus 9 by 16. So 64, 1 minus 4 and 4 are 36. So minus 35 by 64 is the answer for the fourth part. Now we can work out the fifth part. Square root of alpha plus beta whole square minus 4 alpha beta. So 3. So under root 1 minus 16 3 is 48 upon 16. So you are getting a negative term in the square root. So you can leave it like that only because this is a complex root. You need to leave it as it is. Then the fifth part, same thing will be there multiplied by 1 by 4. So the answer will be square root of minus 47 by 16. So these are the answers which you get by substituting the different values. Now viewers, just keep in mind that everything should be reduced in the form of alpha plus beta and alpha beta. So if you are able to reduce everything in the form of alpha plus beta and alpha beta only, then you can think of solving all these problems. Not easy, but you got to remember what to do when a particular expression is given, how you simplify it. So I hope you have copied it. Otherwise, you can always view it later and copy all these things which I have just now told you. Sachin, you want me to explain the fourth part? Fourth part, alpha plus beta whole cube. This is 1 by 64 minus 3 into 3 by 4 into 1 by 4. So you can simplify that and get that expression. So I don't think there is anything to explain there. It is just simple arithmetic. Okay, now let us get on with yet another question. This time the question will be based on the same concept, but the statement will be slightly different. Now see, this is the third question. If alpha and beta are the zeros of, now you are given a quadratic polynomial whose zeros are alpha and beta, and the quadratic polynomial is kx square. Remember there is kx square plus 4x plus 4. Now this is the quadratic polynomial kx square plus 4x plus 4. The zeros of this quadratic polynomial are given as alpha and beta, such that now there is a relationship given. The equation is alpha square plus beta square is 24. Alpha square plus beta square is equal to 24, and you need to find the value of k. Find the value of k. So this is a 2-mark question which can be asked in your board exams, and very important. So Vidhi, Kamalji, now you have understood, at least you have understood that there is something which needs practice. So this is what I wanted. The degree of difficulty should be known to you so that you know how to and how much to spend time, how much time to spend on all these concepts. Sir, I have found out what is the meaning of polynomial. Surendra, you can refer the books there, because I am not concerned with right now dealing with addition, subtraction of polynomials. That will take another 10 minutes in live streaming, and I'll lose the way. So we can have a different session for that also. Okay. Now, if alpha and beta are the zeros of this equation, so the polynomial is kx square plus 4x plus 4. So the value of a is k, because the coefficient of x square is k. The value of b is 4 and the value of c is 4. So we have the values of a, b and c. So what we do after this is to find the sum of zeros, that is alpha plus beta, which is minus b upon a. So that will be minus 4 upon k. So I have put the values of b and a in the relationship. Similarly, you have alpha beta, which is c upon a. C is 4 and a is k. So again, the values of the two expressions is found out using the relationship between zeros and coefficients. Now till here, most of the questions will have the same steps, but after this the steps change according to the content given in the question. Now see what is given in the question here is alpha square plus beta square is 24. Now alpha square plus beta square is 24. Now you need to know how we convert alpha square plus beta square in the form of alpha plus beta and alpha beta. So alpha square plus beta square, if you remember, we have done it in the previous questions also. Alpha plus beta whole square minus 2 alpha beta is given as 24. And now I want you to put the values of alpha plus beta and alpha beta here and tell me the value of k. So audience, kindly substitute the values of alpha plus beta and alpha beta. I have written the values here. I'll just mark it for you. This is the value of alpha plus beta and this is the value of alpha beta. Just substitute these two values in this expression and find the value of k. I'm waiting for your response. Just waiting for someone to solve this and give me the value of k. In the meanwhile, I am doing the first step on the board after this. Alpha plus beta is minus 4 upon k. So if you square that, you get 16 upon k square minus double of this, double of 4 upon k. So that is 8 upon k equal to 24. So if you are aware of cancelling the common factors, you need to cancel out the 8 here. See, 16 is divisible by 8. Obviously, 8 is divisible by 8 and 24 is also divisible by 8. So you can cancel out that 8 throughout and multiply throughout by k square, because k square and k, the LCM is k square. So you can multiply throughout by k square and cancel out 8. So this will become 2 upon k square minus 1 upon k equal to 3. So I have cancelled out 8. And now we can multiply throughout by k square. So this will become 2 minus k equal to 3k square. I have multiplied throughout by k square to get this equation. And now this becomes a quadratic equation which can be solved by splitting the middle term. Now you see, you get a quadratic equation 3k square plus k minus 2 equal to 0. So now you can split the middle term and solve. Already the factors are given there, 3 and minus 2. So you will get 3k, okay, 3k square plus 3k minus 2k minus 2. So you get 3k as common factor, then minus 2 and k plus 1 equal to 0. So if you put them separately equal to 0, you get two values of k, that is 2 by 3 and minus 1. So the values of k are 2 by 3 and minus 1. Not an easy question. You need to have your concepts very, very clear if you need to solve this question. It is a very, very frequently occurring question in board exams, and these type of questions cannot be left, and you need to practice them in order to attain mastery over this important concept. Now I'll give you one more question for finding k. You can do it and let me know the answer for finding k. Yeah, see, the number of responses which I am getting right now is very, very less. It is because the concept is not that easy. So you need to solve this. Mohan, you need a shortcut for this. I think you are at the wrong place right now, because the live streaming is not for telling shortcuts. It is for understanding the concepts. Okay, now the question will change if alpha beta are the zeros of. and something else will be given, and you need to find the value of k obviously. Let us see whether you can do it or not. I'll give you a simple one. If alpha and beta are the zeros of, now the equation is 2x square plus 5x plus k. 2x square plus 5x plus k. Now this is the equation which is given, and such that alpha square plus beta square plus alpha square plus beta square plus alpha beta, the value is given, it is 21 by 4. So you need to find the value of k. So again, similar type of question. So I'm just waiting for your response now. How you got 2k, 2 minus k minus 3k square? Okay, Monica, I multiplied throughout by k square. K square was the LCM on the left hand side. So I multiplied throughout by k square. To get rid of the fractions, that has to be done. So I'm waiting for my students. I expect at least one of you to solve this and tell me the value of k. I'll just help you out in finding alpha plus beta and alpha beta. Alpha plus beta is minus b upon a, so minus 5 upon 2. And alpha beta is c upon a, that is k upon 2. So these are the values. Okay, let me help you with this also. Alpha square plus beta square plus alpha beta, the value is given as 21 by 4. Now see, alpha square plus beta square, I have been telling you on and on again. So this expression is alpha plus beta whole square minus 2 alpha beta. So the formula for alpha square plus beta square is this, and plus alpha beta will come along with this, equal to 21 by 4. So now see, we have converted everything into the expressions alpha plus beta and alpha beta. Now put the values. Now at least you can tell me the value of k. See, I have done half of the work for you. Just substitute the values of alpha plus beta and alpha beta here and tell me the value of k. Still waiting for a right answer. And let me tell you one more thing. These type of questions are not given in NCERT book. So you need to practice them from some refreshers. But the concept is given in the NCERT. The concept of relationship between zeros and the coefficients of a quadratic polynomial. The concept is same, but the questions are not mentioned in NCERT book. Still waiting for a right answer. I've done half the work for you, but it is surprising that I'm not getting one answer also. Okay, finally I have one answer, Sachin. K equal to 2. Simrat, you are saying minus 2. Okay, two different answers there. Let me check with some other person. Is anyone else solving? So we can verify this. I'll just substitute the values here. Okay, a third answer there. Monica minus 184 by 8. 184 by 8. Okay. Vijay Lakshmi minus 2. Okay. A lot of different answers. So we need to verify this one now. Okay. Let me just substitute the values here. See, alpha plus beta is minus 5 upon 2. So if you square that, you get 25 upon 4. Minus alpha beta is k upon 2 equal to 21 by 4. So this k upon 2 can come this side because this is negative. So this will become positive here. And 25 by 4 is already here. 21 by 4 will come this side, minus 21 by 4. So see, 25 by 4 minus 21 by 4. This is 4 upon 4, that is 1. So you cross multiply, you get k equal to 2, which is your right answer. So I think many of you got that wrong, but I should give credit to Sachin. He gave the first answer, and that too, the answer was absolutely right. Kanak, I think k equal to 4, you need to check. I have done it on the board. Kindly check your solution. I think you got it right at the second attempt. Yeah, now many of you are solving this one. Yeah, so you need to take a lot of such questions from refresher books and get on with this concept, because you cannot leave this concept. You still we are left with one more concept, which is still a little bit, you can say complex, because there are more steps involved in that type of question. So I have not solved that question yet, because I need to verify whether you have understood this or not. So let me just discuss one question of that type, and then we can continue that concept in our next live streaming. Now see, this question goes like this. If alpha and beta are the zeros of, if alpha and beta are the zeros of, now the equation given is 5x square minus 2x plus 1. 5x square minus 2x plus 1. So now can be found out from this, but the statement is different now. If alpha and beta are the zeros of this, find a quadratic polynomial whose zeros are 1 upon alpha and 1 upon beta. Now see, important question, and now the statement is changed. So I have taken one hypothetical question just to tell you the steps, but in the subsequent live streamings we will be taking up this concept, and we will be solving 4 or 5 important questions based on this. Raghavendra sir, please provide bank exam quant. Okay, that is a separate issue, Raghavendra. Right now we are live streaming one topic. So I have given you numerous methods for bank exam quant. So kindly see the channel, see the playlists. You will find nearly everything on the channel. There are more than 400 videos. Okay. So now for solving this, the value of A is 5, the value of B is minus 2, and the value of C is 1. So we have alpha plus beta is minus B upon A. So just substitute the value minus B upon A, this is 2 upon 5. And what is alpha beta? It is C upon A, that is 1 upon 5. So once you get the values of alpha plus beta and alpha beta, now we can get on with the remaining part of this question. Now see, we need to find a polynomial whose zeros are 1 over alpha and 1 over beta. So what we will do is, we will find the sum of these two zeros. So 1 upon alpha, this is the first zero, and 1 upon beta, this is the second zero. So we need to find the sum of these two. So take the LCM, alpha beta, you get alpha plus beta in the numerator. And for finding the product of these two zeros, 1 upon alpha into 1 upon beta, this is 1 upon alpha beta. See, I have found the sum of these two zeros and the product of these two zeros, and now I will convert this into quantities by putting the values of alpha plus beta and alpha beta here. So now alpha plus beta, the value was 2 upon 5, and alpha beta, the value was 1 upon 5. So 5 get cancelled, so the value is 2, and the product 1 upon alpha beta. What is alpha beta? 1 by 5. So the value is 5. So you need to find the sum and product of these two zeros and then convert it into the form of alpha plus beta and alpha beta, and then put the values from here to get the values of sum and product. Now the required quadratic equation is, if you remember, we have done it in the live streaming before, x square minus sum x plus product equal to 0. Now this is the equation, quadratic equation. So now substitute the values, that is x square minus sum. What is sum? 2x plus what is product? 5 equal to 0. Therefore, just remove the 0 here because we don't have any fractions or decimals here. So required quadratic polynomial is x square minus 2x plus 5. This is the answer for the question. I am sure you must be feeling uneasy because this is quite tough. Because if you have not followed the live streamings done on the previous 3 occasions, then these things will be surely be difficult for you. So if you have not seen it, see it. Previous live streamings or everything is given in that. Follow them, and once you follow them, these things will become easy. So students, I think this was my duty to tell you that this topic is quite difficult, but I tried and explained it to you in an easy manner so that you can at least study it yourself from the refreshers. Yeah, Vidhi, Sachin, yeah, I think you are following the channel and I'm sure it will pay off. And when you have your board exams, you will surely realize that you have done something good throughout the year by watching the channel. Okay, nice, nice. If you say that it's not much difficult, then with little practice, you will be feeling comfortable with that. So kindly prompt other students, your friends also to join in and tell them that the purpose of this is to give them advantage and not, it is not my aim to practice. I already know all these things. So students need to practice these concepts. They are getting easy access at home. They don't need to go anywhere. So let them just be prepared and watch these videos. So students, thanks for watching. Thanks for your active responses. I hope you have understood. Kindly get on with practicing and I am always there